Hello guys, here we have got a problem to solve that solve this given linear differential equation with higher order having variable coefficient. So to solve this we are going to use Cauchy homogeneous linear equation. This format belongs to Cauchy. Now where we have studied, we have to substitute the variable with e to the power t so that on taking log on each side it becomes log x is equal to t. Then after, to change it in symbolic form, we will replace x dy by dx with dy. Similarly, x square and the second time derivative with d into d minus 1 into y, where d is d by dt. As we have studied like this, wherever there was this, then we are substituting by this. So following this consideration, we will try to convert our given differential equation into symbolic form. So finally, after substitution, we get our symbolic equation like this. Means wherever there was second time derivative and x square, this one, then we substituted there d bracket d minus 1 y, then it is here, and wherever there was x dy by dx, and then we replace it by this dy. Then we got dy plus y. Y is as usual equal to right hand side. Right hand side is what? Log x. And by our substitution we got here log x is equal to t. So it becomes t. So finally it is our required symbolic equation. And now from here we will follow the general process as usual which we were solving previously. First we have to convert it into auxiliary form. Then this is our symbolic form and this is our auxiliary equation. This is its auxiliary equation. Auxiliary equation means the coefficient of y is equated to 0. It becomes auxiliary form or characteristic form. So on doing so, we are going to solve this and we'll calculate the value of d, and there here we get d equal to 1 and 1, which are real and equal. So for real and equal, we know how to write the CF. CF equal to C1 plus x C2 bracket e to the power mx, where m is 1 and 1. Here for the equal roots, we are following this format: C1 x to the power 0 plus C2 x to the power 1 plus C3 x to the power 3 dot dot dot, and finally e to the power mx. But here two roots are unequal, so we will take two terms and bracket e to the power mx. This is the power of e. Okay. Then here two terms there were, so we followed here c1 plus x c2 e to the power x, where m is 1. Then this is our required CF. Then after getting the CF, we have to calculate pi, and pi is equal to right hand side divided by function of d. This one upside is t, means it is like as algebraic form, that is belongs to polynomial t to the power 1. And we have studied that where there is polynomial, we will apply the binomial concept. So our required pi is t divided by t minus 1 whole square, and if we open this square, then we will get this format. Then after solving this, we are going to apply binomial because upside numerator is polynomial, so we will apply binomial. And to apply binomial, we will take the lowest degree term common from denominator, lowest degree term of d, and here is that d to the power 0. So we will take d to the power 0 common, that is 1, and we will get this format 1 minus. We will arrange this behind by taking minus common, so we got this format and hold to the power 1. And if we take this term upside, then we are going to get it in inverse form, that is power having negative. And which form is this? So after here we are going to apply binomial formula, that is, suppose this is 1 minus x bracket to the power minus 1, and we know the formula, that is 1 minus x to the power minus 1 equal to, here is minus minus, so minus minus become plus, every term will be plus. Means here we will write x to the power 0 plus x to the power 1 plus x to the power 2 plus x to the power 3 dot dot dot. Similarly, and x to the power 0 means 1 plus x square as usual. And we know that here t has got maximum power 1, so we will take the term up to the maximum power 1 up to x to the power 1, and we will consider this total term as x, and this is 1 minus x. So we are going to follow the formula up to these two terms only, because the maximum power is 1. So we'll follow that formula where 1 become 1, plus become plus, and in the place of x we'll substitute this total. So this become our required binomial format, where we're going to open this bracket and we are going to send the t inside, and we know where there is d we have to do derivative according to the power of d. Suppose here d has power 1, then we will do derivative of t once, and here d has got power 2, then we will do derivative twice. Then doing derivative we got this result. T is as usual here, but one time derivative of t is 1, so the d is vanished after doing derivative, it becomes 2 into 1. But if we do 2 time derivative of t, then it is going to be 0. So our required pi is t plus 2. Hence the complete solution of given differential equation is Cs is equal to Cf plus pi, where Cs is complete solution, Cf is complementary function, pi is particular integration. This is our expression, and we will return the value of t as we have substituted t is equal to log x, and on doing so we are going to get our final answer. Then what we have got in Cauchy homogeneous equation. First we have to substitute the variable coefficient with e to the power t. We have to substitute the variable coefficient with e to the power t. So on taking log, it is going to be t equal to log x. Then we have to change the given equation into symbolic form by this consideration. Then after, we are going to solve them by the previous method which we have studied already.